Assalamualaikum warahmatullahi taala wabarakatuh. In this video, we are going to discuss about a topic which is the underground cable and how to locate the faults in the cable. So before we start our presentation, we are going to introduce our group members, which is me, Mustaqim bin Muhammad Fathi, and the other two group members, which are Muhammad Hazim bin Mazlan and Nashrul Faiz bin Fatlullah. Okay, so next we are going to look at the contents of this presentation. For the first one, we are going to introduce briefly about the three fault types on an underground cable. For the second one, we are going to explain about the difficulty to locate the exact location of fault. And next, we are going to explain about the overview, principle, advantage, and disadvantage of the Valley loop test and search path reflection. And for the last one is the conclusion and the reference. So for the introduction, there are three types of cable faults, which is the open circuit fault, short circuit fault, and a circuit fault. So this is the example of the mega insulation tester, which is used to detect the fault in the cable. So the first one, we are going to the open circuit fault. The open circuit fault is when one or more cable conductor breaks. It leads to discontinuity. This also occur when the cable comes out of the joint due to mechanical stress. And how we are going to detect the fault is when uh, the each conductor and the earth measured using a megger, and it is characterized by infinite resistance. For the observation from the megger, uh, when the megger connected between the conductor and the earth, it will read the infinite value. So this conclude that the circuit is an open circuit. If the megger indicates zero resistance, so that means the conductor is not broken. Okay, now for the short circuit fault, it only occur in multi-core cables. It is when two or more conductor of the same cable come in contact with each other. And so how we detect the fault is when the short circuit characterized by zero resistance. The resistance between the two conductors is measured using the megger. Also, for the observation, if the megger is zero, so that means the conductor and the cable is a short circuit fault. For the circuit fault is when the one of the conductor came in contact with the earth. It occur because of the outer sheet is damaged due to chemical reaction with soil or due to vibration and mechanical crystallization. So how we can detect the fault is when the megger connected between the conductor and the ground, and megger reading is noted. So how we observe it, if the megger show nearly zero reading, so the earth fault is present.
For the next part, we will continue for difficulty in finding fault in underground cable. So as we investigate, there are three main factors that difficult to finding fault in underground cable, which is the first one is visual method. The second one is the structure of underground cable itself. And the lastly is a technician error. Moving to the first point of the difficulty in finding fault in underground cable is a visual method. If we able to make a comparison between the underground cable and also with the overhead cable, uh, the location of both cable is different, which is underground cable located under the ground. Meanwhile, the overhead cable is located hanging in the air. So, as a comparison, visual methods are totally accurate to finding fault in underground cable. Meanwhile, overhead terminal is easy to find. So that's why underground cable is very too hard to locate the fault because we cannot see with our eyes. We need to use the Valley loop or other method. So moving to our second point, which is the structure of underground cable itself. Underground cable structure is a long cable and also has a very jointed and have a lot of branch. So with that, it's required a lot of time and hard to find the exact location of that fault because as we know, underground cable is not like a 5 meter or 10 meter. It's like 50 to maybe 1 kilometer long. So we need to find for each kilometer or meter for the fault, and because of the cable is jointed, so maybe it's not in the branch that fault, maybe it's in the from the before the branch. Lastly, the technician error. There are many errors that can occur during finding the fault in underground cable. Maybe the equipment or the technique that used by technician are inaccurate, or the equipment are very old that cause the error during the process. So with that, technician must uh, do a lot of precaution steps before finding the fault in the underground cable, because underground cable is not an easy to find its fault because it located underground that we cannot see with our eye, and also the underground cable is a very long and it has a many branch that we cannot just find the error in such short of a time. So with that, the technician must do the precaution step and to reduce the error while finding the error in the underground cable.
Okay, for this part, overview of the popular method, which is Bartley loop test. Bartley loop test is also locating short circuit and faults in underground cables. This test also employs the principle of a Wheatstone bridge. However, the difference between Murray loop test and Bartley loop test is Bartley loop test is resistant R1 and R2 are fixed, and a variable resistor is inserted in the fault lab. If the fault resistance is high, the sensitivity of Murray loop test is reduced and Bartley loop test may be more suitable. Okay, for the principle, we have two diagrams. On the left, we have Bartley loop test for a fault, while on the right, we have for short circuit fault. For the resistor, R1 and R2 is fixed, while the resistor S is a variable. In this test, the switch K is first thrown to the position 1, then the variable resistor is varied till the galvanometer is zero deflection. Let's say the bridge is balanced for the value of S equal to S1. Then now the switch K is thrown to the position 2 and the bridge is balanced by varying the resistor S. Say the bridge is balanced as value of the resistor S is equal to S2. Lastly, we put the result of equation 2 in equation 1 and we got Rs equal to R1 bracket S2 minus S1 divided by R1 plus R2. Since the value of R1 and R2, S1 and S2 are known, Rs can be calculated. When Rs is known, the distance from the test end to the fault point Ls can be calculated as Ls equal to Rs divided by R, where the R is resistance of the cable per meter. Okay, the advantage first. Bartley loop test can locate the fault. And second, the test also employs the principle of the Wheatstone bridge. However, the difference between Marley-Loop test and Valley-Loop test is that in Valley-Loop test, resistance R1 and R2 are fixed, and a variable resistor is inserted in the fault leg. If the fault resistance is high, sensitivity of Marley-Loop test is reduced, and Valley-Loop test may be be suitable. For the disadvantage of Valley-Loop test, Valley loop test is valid only when the cable sections are uniform throughout the loop, and the current flowing through the cable would cause the temperature effect. Due to the temperature effect, the resistance of the cable would be changed. Thus, we need to apply less current to the circuit to carry out the experiment. Okay, for the next part, we have other method, which is surge pulse reflection method. This method uses a current coupler, a tamper, and a storage oscilloscope. This method is used for a run cable and a fault that are difficult to arc over which do not show up using arc reflection method. In this method, a tamper is directly connected to the cable without a filter, which can limit both voltage and current applied to the fault. The tamper injects a high voltage pulse into the cable, creating an arc at the fault, which subsequently causes a reflection of energy back to the tamper. The reflection repeats back and forth between the fault and the tamper till its energy gets depleted. The current coupler sends the surge reflection, which are then captured and displayed by the storage oscilloscope. Principle for pulse reflection method. For the pre-location of the fault point in an electrical cable by pulse reflection method, the pulse reflection method uses a pulse of suitable shape and width, which are transmitted into the cable to be measured in a periodic sequence irregularities in otherwise homogeneous wave resistance cause reflection, which are caught at the start of the cable. The pulse which are fed in at one end of the cable and travel along the cable with a certain propagation velocity Vp, a change in the characteristic impedance Z of the cable reflect them to the start end of the cable. In other hand, the pulse traveling from the reflection point back to the beginning of the cable is called pulse with echo. The time delay between sending the pulse and receiving it back in a faulty phase is used to calculate the distant fault point, following the same way in sound phase used to determine the total length of the cable, and only low resistance fault and breaks open circuit can be located with the pulse reflection method. Also, coupling fault can be located. Okay, the advantage and disadvantage for the pulse reflection method. The main advantage of this method is its ability to detect difficult and distant faults, while its disadvantage is its high output surge can damage the cable and the reading trace require more skill compared to other methods.
So for the conclusion of this presentation, after we know about the fault of the cable, we can enhance the power quality and restore the power supply in time. Also, from this presentation, we will know the difficulty in finding faults are really hard, but with much detail and the right method, we can locate at the fault. And the third one, after we apply the value loop test, uh, the value loop test is a great importance to locate and classify the fault rapidly and accurately. So for the last one, this is the reference of the completion of our presentation slide. So that's all from our group. Thank you for listening.